Thanks for joining, everybody. We have some friends from Brazil, some friends from California, some friends from Germany, and some friends from Brooklyn, New York. So welcome, everybody, to this second bazmarc session. And today we're going to be talking about the EV3 printer that I designed earlier this year. No, earlier at the end of last year. And the idea was to use a low-cost pen that I got from the internet, made in China. These go for about $50 US, and they take some filament through the hole here, some power here, and then you have some buttons for the speed of the filament and pushing the filament out or like outwards or extruding it. And so those are the two buttons, and what I did is I glued this one to the Lego frame, and then I just mounted a little motor to press on the button here.
Mark, did you use Sugru to glue that on?
Yes, in fact, for this one I used Sugru. For those who don't know, Sugru is a little compound like this. It's called Sugru, and it comes in a little pouch. You open it up, and it's like Play-Doh. It's like plasticine, and you shape it, and when it dries, it stays rubbery. So you cannot remove this. This is glued forever. On another pen design, I was able to. Let me switch cameras here. On another pen design, I was able to actually mount the pen by bracing it between Legos. I think that this is a more elegant solution. Also got Maureen on this call because this becomes now a very interesting project for school, where we have to learn about science, technology, engineering, mathematics, and art. So I'm going to let Maureen, would you like to start a little bit about the STEM program, or should we start hearing about the programming itself from Thomas?
I think maybe I'll just start for like 2 minutes, and then I'm dying to hear from Thomas, and then I'm going to step off because I actually have to go teach in about 10 minutes.
All right.
But from my perspective, I fell in love with this project the second I saw it at Maker Faire. And I knew I wanted to recreate one as an inspiration model. I teach in an all-girls school in New York City, and I teach kindergarten through 5th grade, and then I also collaborate with our middle school and high school STEM teachers. And I'm, first of all, from an engineering perspective, I think constructing this model or constructing any type of printer where you're exploring the X, Y, and Z axes is super powerful.
Let's hear a little bit about how this was programmed by Thomas, and then we can come back to my printer and look at the details and how it was built. Thomas?
Yes, I'm here. I hope you can hear me, you can see me, and you can put me on recording. Is that okay? Can I get started?
It's all done.
Okay, great. So I'm going to try to share my screen here, because that's more fun than my video. Hopefully that also works. So basically that is the main part of the program. You can see it's all in EV3. But it doesn't make sense to go through it line by line. So I thought I'd give you a bit of an introduction to the Mars. You love the red blocks. And Andre said it shouldn't be a lecture, but I realized I need to draw some things, and before I draw them on a piece of paper, I thought I could as well draw them in PowerPoint.
Very nice.
It's a pity that Maureen is not here. By the way, this is my friend Heinz. He travels with me a lot.
The little figure.
Yep. So
Maureen is going to get to see all this because it's now being recorded. So that's good news.
Okay, good. So I think in another life, Andre already You made already an introduction about the polygons. So this is really the story. If you want to do a circle, what you actually do is you do lots of small straight line segments. So if you do 4 lines, you have a square, 8, 12, and so on. And the more you do, in the end, many, you have a circle. And the printer resolution, this is something that you should rather talk about because you're the hardware man. So the printer resolution, of course, is limited. So you don't need to go to unlimited number of line segments. But what did you do in real life? How many did you do? He's gone.
What do you mean?
The question was when, in the end, you looked at a circle. It wasn't a circle, but it had a certain number of lines.
I use 5.
No.
I use
5 degrees. Okay,
yeah.
We come to that. Okay.
Because it really doesn't make a difference. If you do 1, it takes more time. One basically does.
Okay.
5 will do.
Yeah, we're going to have a look at that in a minute.
Okay.
So basically, there are, from a math perspective, there are 2 questions. One is how do you plot a straight line, and the other is how do you calculate all those starting and end points. So assuming you can do 1 straight line, how do you then calculate where you want to start and where you want to end? And by the way, interrupt me if you have any questions. So, Mark, you already said that going straight and you have an XY printer. So here's a little sketch that says, okay, basically going from start to end means you have to move somehow in the X direction and somehow in the Y direction. And of course, you want to measure the distance. And when I say distance here, you can immediately translate that to motor degrees. Of course, there are some gears and stuff technically in the printer, but in the end, when it says distance here, that's only motor degrees, right? So I keep talking about distance, but whenever you want to think, you can also think motor degrees there. On the left, you see that such a distance could also be negative. So whenever you see this orange arrow, that means that you have to rotate your motor into negative degrees, apply negative power. So both can happen. Okay. So the question is, when we have those 2 motors, what do we do? The first thing that I did, by the way, I didn't have the printer. I only had 2 motors connected to my EV3, and I was watching what they are doing, how they are turning. So the first thing you could do, you could say, okay, I do the x-axis first, and then I do the y, which will not give you a straight line. It will give you such an angled thing. That is not what you want. The second experiment I then did, I said, okay, wow, I can run both in parallel. So I switched on both motors at the same time, and the outcome was still not the straight line that I want. When you look at this, the reason here is that the x distance is longer than the y distance, which means the y part is done while the x part is still running, right? So in the beginning, they go both nicely in parallel, and that is not what you want also. So finally, what you need to do is you check what is the longer distance, and for the longer distance, you give that motor lots of power. And for the shorter distance, you adjust the power downwards and give the shorter distance less power, which means the motor doesn't rotate as fast, which means that the distance is not done as fast as with the longer distance motor. Okay so far?
Okay.
So here comes the math. Starting at the top, the distance that I talk about here basically is power times time. Obviously, the more power I give the motor, the faster it runs, the more distance it does, and the more I run it, the longer I run it, the more distance I get. It's like with a car, right? Where you just, when you drive longer, you get more distance, and when you drive faster, you get more distance. So the first thing we do, we just turn around this formula here, and so that we have the same equation again. It's the same equation, time equals distance divided by power. And then the only clever thing happens here that we say, okay, now I have my x distance and my x power, and I have my y distance and my y power. And I want both to be done at the same time, which gives us this equation here. right? X distance divided by X power equals Y distance divided by Y power. And one step further, you say, okay, now, okay, I look at this and I transform this formula. So in the end, I have Y power equals something, and that something needs the X power. So going back to the example, X is the longer distance. Longer distance gets lots of power, and the Y power is scaled down linear to the ratio between the Y distance and the X distance. That is basically it. And when you look in the code that Andre has shared, the stuff that I created, you will see exactly those 5 steps going on there. First is you calculate the distance, because your motor degrees is at a certain point, and you want to go somewhere, so you need to calculate the distance for X and Y. Step 2, you identify the longer distance. Step 3, the motor that drives the longer distance gets the full power or base power. Maybe you don't want to use 100, maybe you want to use 80, but definitely the faster, the more powerful. And then using the formula from the last slide, you calculate the reduced power for the other motors, and then you run both motors in parallel. So let's maybe start with this go straight block. This is something that also fits here on the screen. I think you can see that okay.
Yes.
There's the magic block go straight power, which does exactly the calculation I just talked about. And the outcome of this block is you have motor degrees and you have power. So I can take the power, the X power and the X degrees, throw it into one motor block, and I can take the Y power and the Y degree and throw it in the other motor block. And these two run in parallel. Theoretically, they really end at the same point of time. But to be on the safe side, here you see a nice mechanism to make sure that they really end at the same point of time. What's basically happening here is there's a Boolean, a logic variable set to false, and then the B motor is run, and it waits, after the B motor, it waits that the variable becomes true. But the variable can only come true if the C motor has finished in parallel. So this
this trick can be used for many other use in FLL and things like this, right? Where you want to make sure that the two motors finish at the same time. This is a good trick.
Yeah, it's not necessarily about motors, it's about parallel branches in your code. If you want to make sure that both are finished, that's the way to do it. And you can even do it with 3. If you have more logical variables, you can even expand the concept, but we only need 2 here. Okay, so basically the magic happens here. In this block, the power is calculated. And if I go into this block, this is the one I started with, and you have a look at this. I scroll to the left first. Hope it works. Comments in there. In the beginning, it's about figuring out what is the distance for the X dimension. And I take the absolute value here because the negative dimensions is something to deal with later. So figuring out what's the distance and do we go backward and forward. In here is really here dividing. This is dividing the two distances. This gives you the ratio that helps you to power down the motor that has the lower distance. And then the power is
Thomas?
Yeah.
Oh, sorry. I thought you went blank for a second there.
Okay. So maybe because I was scrolling. So in the end, the directions, sorry, the distance on X and Y and the power on X and Y, they come back, and this is all that's happening. So the only real key thing is here. I just page back is this little formula to scale down the motor that has a shorter distance. That does the trick, and then you can go straight lines. Okay, good. Second question, how do we calculate the start and end points? And this is where trigonometry comes into play. If you ever remember from whenever you learned it, I tend to remember those things. The dashed curve here is the sinus curve, and the other one is the cosinus curve. we don't need to talk about where they come from, but when you look at what they do is here, the sinus starts at 0, goes up to 1, goes down to 0, goes down to -0, and comes back to 0. And this is exactly what we need here. And in this case, we are plotting a little square. We need to start at x 0, then go to x1, go back to x0, and then go to x -1, and then go back to x0. This is what we get out of the sinus curve. And in parallel, we get out of the cosinus curve, we get something that starts at 1, goes down to 0, goes down to -1, comes up to 0 again, and goes up to 1. So even if you don't understand how it works, the thing is you just use it, and the more points on this curve you pull, the more little straight lines you get. And what Henry was saying, sorry, Mark was saying is he used 10 degrees. So actually you didn't do a circle, but you did do a 72 edge something.
10 does a not bad result. 5 does a okay result, but in any case, because of the Lego printer, you're always going to get shapes that are not perfectly round.
Yeah.
And this, we'll talk about that afterwards, but it has to do with the slack in the Lego itself.
Yeah. So to create a circle is really then pretty simple. You use here, you see that in the formulas down there, you use the sinus and the cosinus as I just had it on the slide, and then throw it into the go straight function, which means one line, another line, another line, until you have everything done. There are 2 things you need to consider. I'm going back now to the sinus again. This gives you numbers between 1 and -1. But in reality, you want to rotate your motor a couple hundred degrees, maybe. So you need to scale this up, right? These values here is not good enough to really drive it. So somewhere in the code, you need to say, okay, I multiply this maybe by 2,000, and then my motor goes from -2,000 to +2,000 motor degrees. That's the one thing you need. And the other thing we already discussed, the resolution. How many steps do you want to do? We just heard 5 is a good number, 10 is also quite similar. So this star subroutine circle one looks like this. Exactly what I just said, right? So you take the counter here, you multiply it by the degrees, and then you go into the sinus and the cosinus and call the go straight function. The rest you see further to the right is just nice. It puts the coordinates into the display, so you can see if you have a mechanical defect. So if in the display you see that all the dots are done right, but your plotter is not plotting as you expect it, then likely you have a mechanical issue. If you look close, you see there is something that says X mirror and Y mirror. This is something that we had to introduce because I think you changed the gears or something, and suddenly everything rotated in the opposite direction. That are the hardware factors, right? The scaling factor that I already talked about, and the other factor that takes into consideration if your motor, the X and Y axis, if they are mirrored or not.
So basically, if your design of printer is different than my design of printer, it's easy now to flip the signs.
Yeah. Yeah. At the bottom of the code, you set the X mirror and the Y mirror to either 1 or -1, and then in all the formulas it's used automatically. And I don't have any slides about the star, but we can have a look at the star. The star basically is the same like the circle, but with every second one, it takes a smaller radius. Right, so it's alternating between the outer radius and the inner radius. Otherwise, it's part here. The mirror, sinus, mirror, cosinus, this is exactly what we looked at. And the only difference that's really happening is that there's an inner and an outer radius, and using a logical variable, it's flipped. So one point is out, the other is in, the next is out, the next is in. So this is why actually you're doing something like 2 circles at a time, the outer circle and the inner circle, but because you go straight line without stopping the pen, it becomes a circle shape, sorry, a star shape.
Which really is the shape that comes the best out of this printer. From experience in printing all kind of shapes, the triangle and the stars are probably the most fun shapes to print. I don't know why. Perhaps shapes like, let me zoom on. Shapes like these. Hello? Come on.
Yeah, yeah, go.
I don't see it. Oh, okay, weird. Shapes like these. Now, the ones I'm showing you, the ones that are all colored, are from earlier versions of the printer. But you'll notice that these bars are longer than these bars. Like, they're not perfect shapes. But again, that's the problem is not with the math. The problem is with the slackness of Lego. And then when you have
yeah,
the square comes out good, but the square comes out like lozenges. It doesn't come out like this, of course. It comes out like that, which doesn't really matter. But
yeah, so maybe just two thoughts on that, because the way how I showed you the mass and we did some experiments, the power is scaled down for the motor that has the lower distance, which can result into very, very low power calculation if there's only few distance degrees.
If the slope is very...
Yeah, and therefore we introduced a lower limit, and if the calculated value is below the lower limit, then the lower limit is taken, which does not result in a straight line. It cannot. It goes back to the second scenario that I had on my slide, that one motor is finished and the other is still running. So I think when you go really crisscross and both have long distance to travel, then it should be very accurate. But when you go in one dimension long and then the other nearly nothing, then it becomes a bit shaky. And I don't know from a mass perspective how to fix that.
So probably that's why my circles have a little bit of an oval shape, or not oval, but you can notice a straight line, and then it curves, and then there's a straight line, and then it curves.
Yeah.
So once this straight line block was done, and the other equation for actually drawing a given polygon, afterwards the amount of edges that you have, whether it's a square, a triangle, or a pentagon or hexagon, is just changing the variable in the my block. And so the part that I did was create a nice little menu where people could pick the shape they want and then pick the size they want. So the program was so well done that it was very easy afterwards to adapt it and to turn it into a fun program that kids can now try different shapes when they're at events. And one of my goals was to make some rings that people could wear as they walk away from the kiosk. They could wear the shape they've done, and that came out pretty well because, you can walk away with your little star or make fun objects like glasses or something. So this was great, but then I've had some challenges. I've had some kids asking me. This little girl came to me and said, "But Mark, can you print a heart?" And I'm like, that's such a good idea, but I can't print a heart right now. Even though a heart would be like 2 circles and a triangle, I could probably mix-match something up, but we are going to try to do another version of the program where now, instead of reading, and correct me if I'm wrong, Thomas, but I think what I understood is instead of reading the coordinates from the sine and cosine, where we're getting all the dots to create the polygon, we would now read the XY coordinates from a table, and basically to generate this table, you would take some checkered paper and draw your shape, and then write down the coordinates of each line, the points from which to go to, and we would input that to the program using the same go straight my block, and I could basically print any shape I want.
Yes, I mean any shape. Of course, it's a big promise, right? But what we would do is we would generate a text file, likely on your notebook, which always contains 2 coordinates, and then the core loop in the program reads 2 coordinates, goes straight line, reads the next 2 coordinates, goes straight line, and so on until end of file. And then it's up to you to determine, right? So whatever you then, the sequence of coordinates that you put into it determines how the printer ink, no, it's not ink, filament is put down.
Well, you mentioned ink. If you don't have one of these, right, because first of all, they take 6 weeks to arrive when you order them from those China websites, there's nothing that stops you from mounting a marker on some Lego rig. If you can make, because we're basically doing a printer here, it just happens that I'm taking out some ink. And then what we do is we repeat the step of the shape and we just raise the pen every time. But if you want to practice and test formulas at home, you could very well print on paper the shape. And if it comes out good on paper, you're going to get very nice results with the pen as well, because it's basically the same thing. The only thing that we do afterwards was raise the pen at each iteration in order to get the thickness of the object. And in fact, I had fun with that now, because if I keep on going, and I don't have any samples here, but you can create some cylinders. Like, here's one larger example here that I made on another printer. But I also made the radius smaller as I went, and then I was able to create little objects like, let me get one that's in color, because I'm not seeing a lot of contrast here. Here's one I just printed earlier. So it's always the same program, just adapted differently. So,
Mark,
yes.
just a correction. So anybody thinking of building this isn't discouraged. You can get the pen off Amazon. It's hard because some of the brands, they have, like, one of them have like false advertising. So, but it's possible. I found one. Maybe I'll put a link in on YouTube or something. But
yeah, actually, this exact pen is the one you got, Cyrus?
Yeah, the exact one. I get print in PLA.
Yeah, so this exact pen is also available on Amazon, so it takes much less time to arrive. Except on Amazon it says, oh yeah, you can use PLA with it. And it's not true. You cannot change the temperature. This pen will only do ABS. Now, ABS is great, but the fumes are toxic. And so when you're working in your room and you spend all day with your nose in the printer, at the end of the day you're like, oh, that was fun. Because, well, you've been inhaling toxic ABS all the time. So switching to there's other pens that have adjustable temperature, and then you can use PLA filaments, and they don't have any fumes. So if you're working in a closed environment, I think it's a better choice, especially if there's kids around and all that. I've tried to make a larger one, like Cyrus's. Here's a design that I made of a larger one. But the problem that I have is, you know how the slack that you get on the mechanism, you will see that it will have an effect on the shape that you're printing.
Mark,
yeah.
Are you using the same modules that I was? You know how mine had, I didn't put the beam on the bottom? Because mine has very little slack.
No, exactly. And I've reproduced yours. I've reproduced the design of yours, and it's indeed very interesting because there's almost no slack in this. So this is something that I might try at some point, because my design is fun, but the largest object that I can print is about an inch, or 5 not even 3 centimeters. It's not very big.
I think mine will be 12 centimeters.
Yeah.
12 centimeters by 12
Let's
centimeters.
switch cameras here. But while we have Thomas on the line here, Cyrus, one of your goals is to be able to read 3D printer files.
Mm-hmm.
What are those? Are those more? I've actually haven't really studied those files themselves. Are they more than just XY coordinates?
Okay, so when you have like your 3D model, you export it as a STL, which is the model for it's actually like the model. That's the file that the program uses, and then you convert it to a different file called G code, and the G code it basically auto generates like a script for your program to follow, and it has different commands. So like I think it's G1 is for motor movement, so it tells you the coordinates, and then your printer has to interpret those coordinates to move the print head. And they
that's
have different
standard. A standard for 3D printers.
yeah, it's pretty standard. Yeah, and then there's different commands for like the heat the nozzle, or for coolant, or like the spool. Yeah.
Like turning the nozzle on and off. Because in the case of these printers, or at least a printer made using one of these pens, and let me take the focus away from Thomas here. It's not really good with cutting it off, going to another point, starting it in again, and then doing another shape. It's better for a continuous shape. So, for example, if I want to make a printer that does the EV3 logo, I could make this shape no problem. But to make this whole thing out of my printer would require the pen to, stop printing, go somewhere else, and start printing. And that's not very obvious to do with one of these. Because when it stops, it doesn't really stop, like, sharp. And then when it starts again, you got to kind of, like, clean it. And so if I would want to do this, I would have to do it in actually 3 parts and assemble them afterwards. So that's something you might want to keep in mind, Cyrus, when you design, where the shapes that you're asking it to print.
Yeah.
Yeah.
But even in the standard 3D printer, this is the same problem with this kind of 3D printer that use hot filament.
Oh, so when you have to stop and start somewhere else, it's always an issue, regardless of...
Yeah, I have 2 3D printers in my college. The same problem. The model needs to be continuous and with no gap, because if you have a gap, you need to put some support material and remove after the end of the printing process.
So you need a printer with two heads.
Yeah. We can't control the precisely the amount of material that comes out from the printer head.
Okay, I can do that too manually. If we come now, let's do a little demonstration of the printer. If some of you haven't seen it, over here. All right, so here's the menu that I made. So I can pick stars or polygon. So let's start with the star.
It's 1 o'clock.
I can pick preset variables here. So we're going to pick like number 7, which is the middle here. And then I'm going to print a large one, so bottom down. I'm going to make a big inner circle. And I want it thick. And so now it's doing the XY. Touch sensors allow it to know when the zeros have been reached. Then it moves to the center. And then the pen will come down. push the button to extrude the plastic, and start printing.
Mark,
Yes.
I think I found. I was thinking. Remember, you said the problem with the leakage on the tip of the nozzle.
You think
that?
you found what?
Remember the nozzle? It leaks a little bit. So you have that problem. I've seen in other 3D printers, what they do is they wipe the nozzle, like the printer goes to the side and then goes down and it wipes it on the build plate. I think that might be a solution.
Oh, you could have an automatic nozzle wiper.
Yeah, I've seen
out of Lego. That could be an interesting challenge.
Mm. Yeah.
Sorry, my phone went into low battery mode here. So, I was all very proud of this latest design that I made here. It turns out that it doesn't work as well as my previous one because I have to modify a little bit the program. But this is the one that I've built that uses the pen that allows PLA printing. But I'm going to use this now to show you a little bit how I've built it. So again, those who know me know that I'm a big fan of rack robots with rack and pinion, which we talked about a lot on the previous Hangout. Jeez, PLA is harder to cut than. Anyways. Well, this is basically. I'm going to remove it from the. You have an assembly with the pen attached and a motor to allow the rack to go up and down. And this is just a guide to know when it reached the bottom. So it presses the touch sensor. And what I've done is I've used linear actuators, which are, the motor goes straight into the linear actuator. And so I get very little slack now because, well, there's no gears or anything like that. And so this design is fairly simple. It's what I've been using for most of the printers. But I think it's time now to move into something bigger and possibly use Cyrus's concept of the rack and pinion like this, where the way it's done now, there's very little slack, and this thing, there's almost no play at all. So I think we could get a pretty good precision with this. So yeah, there's always some improvement that can be done. Anybody have questions specifically, either on the programming or the building of this robot? Let's see how our star is doing. I don't know, but watching this thing print is always fun.
Well, how many time did you spend to?
You see, Thomas, how it paused for a second there?
Yeah.
I don't know why. I can't figure it out. There's no delays whatsoever. But it's at the moment of going up that it kind of thinks. And I don't know what it's thinking about.
Did you ever use Bluetooth connection and see which block is executed at that point of time?
I know what you mean, like to be able to see the program live.
Yes,
but
you can see. Yeah.
Yeah. I think I have, because I've printed this very often with the brick plugged into the computer. But
Okay.
it's really not long. Like, in terms of time, it's not long, but it's long enough for creating that little bulge on the shape.
Yeah.
I think this is the last. It now went up, and you see it created a long filament.
So to your question, you never know if at the bottom of the programming stack there is something like clean variables every couple of seconds, or something is being removed, garbage collection or something. So system-related processes that run every so often.
So that, like I said, it's more of a firmware issue or something. Probably if we use something else, then
Yeah.
So,
I remember from first Lego League, when we were writing log files to later see what went on during a run. It turned out that every couple iterations, the log file was really pushed onto the brick. In between, it went smooth, and every couple seconds, suddenly it was like dumped. And then it ran smooth, and then it was dumped. And it was really, you can see in the files that it was not increasing linearly, but every so often it was a big chunk that was added. Beautiful shape.
So it's really almost perfect. I mean, each triangle is pretty much the same. I mean, it's beautiful.
Mark, guys, I think I'm gonna have to go. My class starts pretty soon.
All right, school first. Thanks, Cyrus, for joining in, and we look forward to seeing your development on your printer.
I think I'll comment
See
on
you,
the
Cyrus.
YouTube video information. Okay.
Cool. Thanks.
Okay. Bye, guys.
Bye.
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 Mark,
Yep.
is this a resistant material?
This is ABS, so I am using my older printer, which prints ABS, and ABS is the same material as Lego.
Hmm.
So
Sure.
the shape that I've printed here now is a little bit flexible. But if I push too much, then of course I can break it.
Yes.
It's not very hot when it comes out. You can touch the this part here. The nozzle itself is hot, but when the filament comes out, it's not too hot. Let's have a look here again at the menu. Is there a specific shape you would like me to print? Maybe a star with more points, or a polygon? Anyone?
Make a sphere, make a semi-sphere. Just
I don't have that program, so basically I make a circle that becomes smaller and smaller and smaller.
yep.
I have a star that becomes smaller and smaller and smaller. In fact, here I got a program that's called 3D Star. Okay, and that's an interesting one because it's one of the only programs I have where, you know what, one of the let me plug my phone and go. One of the you see it's starting like a little blurb. It's actually going to print like this, and then like this. So it's not going to make a sphere, but it's going to make a star, starting very small, becoming bigger, and then the opposite again. So this is called a cliff hanging because, like when you're going up a rock wall and you get to a point where you're cliff hanging, and this is a test that they use for 3D printers to see how good the printer is. It's if it's able to print like this in a negative slope. And here's the program that Thomas added, where it's actually showing on the screen the dots that are being, the straight lines, they're going from dot to dot.
Yeah, I needed to do it like this because, as I said, I didn't have the motor. So at least I wanted to see if the calculation of the dots is right. So putting that into the display made a lot of sense. And I believe, Mark, it will also come handy when we do the next thing, reading the coordinates from a file, because then also in display you could see if that works, I guess.
That would be really cool.
Should be, yeah. I mean, this comes right out of Go Straight, right? Or does it come out of Circle? No, it comes out of Go Straight. Maybe it comes. I have to check. But anyway, it's a good debugging mechanism. That was the idea. Okay, guys, I have to leave. The slides I created, I shared them with Mark. Feel free to distribute. I sent you the PDF, and if everyone wants to have it or has questions, I'm on the Facebook group. You can find me.
Thomas,
spread the code.
I'm going to zoom on you here for a second. Thank you very much for your time and joining us. And I look forward on working on new versions of the program.
Thanks for having me. Bye.
So that was Thomas Medea from Germany, who helped me with the programming of the EV3D printer. Somebody just joined in. Iko. Where are you from? Okay. Look at that guy. That would be a good time to put a piece of Lego inside. It's hollow. I can hide something inside now.
And EV3 bricks.
Yeah, they're a little bit big. But oh, I've printed so many shapes. It's like crazy. I've got like, you know, I've got boxes and boxes of shapes that I've printed. But now when I go to events and I print shapes, people leave with them. And that's always a very big win. When people can leave with something, they leave with their own star. They're always like that. So if in this program, instead of using the star shape, I had used the circle shape, technically I would actually be doing a sphere.
Not.
There's something.
It's easy if you calculate, because it's not a linear proportion of each layer. Is an equation. That's another circle equation for the.
Yes. Yes, of course. Because it's basically.
It's almost the same idea, not just the ratio of the slope is not linear. It depends on.
Yeah, I know what you mean, because I'm always going to get like an egg shape, not egg, but oval shape, if I do it this way.
Yeah, but it's easy to calculate this. This is every engineering study learns this in the first year of the school. It's easy.
Yeah. I know this hangout is not good for my reputation, because these are things I'm supposed to know.
No. Come on, man.
But
you know a lot.
But you know what this translates to. If I had Mindstorms, if I had an EV3 back in the days, I think I would have understood a lot of mathematical concepts so much better, because I would be hands-on, I would be trying stuff, right?
This is what I'm doing with my students in my classes. building STEM things to better understand the engineering concept. It's very abstract for all those kids.
Exactly. What do you think, Louis? Do you think this helps to understand the math behind it?
Sure. It gets so easy.
So now we have this shape that I made. Interesting Christmas decoration. Pretty cool when you think that it was done by a Lego printer.
Yeah.
And another one that's fun to print are these those Christmas trees, you know, the cones, like these guys. It is another. We have Marc-Andre. We have another Marc-Andre on the line with us. I think he's just being curious here. You know that Marc-Andre, that little Lego figure that you see on the. There you go. This guy is a stop-motion animation master.
Thanks.
All the stop-motion videos that you see going around on my wall and all this are all created by this guy. He's like awesome. He's done some very known ones like the couch gag with the Simpsons and the monster. I don't know what it was called. Something monsters and
How to build a monster.
how to build a monster and all that. So he's actually started using Mindstorm's EV3 for creating some rigs to help him with his stop motion videos, and so that's why he's got a little bit of a you know, the Mindstorm has a little place in his heart because he does animation, but he also uses Mindstorm to help him with that. And yeah. Do you have any questions, Marc-Andre, with regards to my printer?
I'm really looking forward to maybe ask you to print some stuff for me, because in stop motion sometime they print the face of some character, like in the Paranormal, the one of the last stop motion movie that came out last year, Paranormal. All the face are 3D print and then paint. But some people, what they do, it's like, let's say you want to have a little monster of just a worm that will move. They will print each shape of the worm doing his thing, and then replace it in every picture.
Yeah.
So if you have like 8 of them, you can print them. So I'm looking like,
so that's nice, but it's no longer a Lego stop motion afterwards.
that could be included into it, yes.
And also, as you notice, this printer does very basic shapes. So maybe after, with the new version of the program, we'll be able to do more interesting things. In any case,
the beginning anyway.
Yes. So thanks for joining in, Marc-Andre.
No problem.
In any case, I think that we are going to wrap this up. Unless anybody has specific questions that can be answered with regards to the building.
About the software, Mark, have you ever think about to integrate some external program software that like computer vision, that you can draw something in the...
Actually, you guys are familiar with Bricasso?
No.
Is the printer that that made this?
Ah, okay. A printer that
from
I think I saw in the group is a printer that pick up the bricks and place. Okay,
yes.
Yeah.
But to do that, he actually has a color sensor that reads the shape. So it reads the color, it reads what brick it's supposed to be picking from the banks, and then it makes the shape.
Okay, but I think you will have. I think you will have problems of resolution.
Yes.
For the 3D printer doing by the way that you are doing. Yeah. I think you have the problem. SASEC in Brazil developed some. It is not a 3D printer, but is a machining center that machining the sponge, the floral sponge. Let me see. The Arthur Sasek, do you know the MCP from Brazil?
Which one? Arthur.
Arthur, yeah.
Yes, yes.
Have you ever seen the milling machine?
Of course, of course. He was at the WRO in Abu Dhabi.
Yeah, he used this concept. He makes a text file with the coordinates and divide by layers. This is the same idea, but with a higher resolution.
Well, the program that we're going to do next with Thomas is a program that's going to be able to read the coordinates in a 100 by 100 matrix, right? And
yeah.
Basically, if I want to do I don't know how it's going to work, but if I want to do a shape, I could probably do something like this. I guess straight lines would be easy. You know, if I do something like this, then I could import the coordinates. I would say this is position 2, 3. This is position 3, 2, and so on and so forth, and input those values to the program, and it would make that shape, which would be different from a star, right?
Okay, but you don't need to only think about the vertices, the corners. You can do the same idea with all the points. It's a matrix.
Yeah. You mean you could have every single point in between.
Yeah.
And have a curve.
You don't need to draw lines or circles or pre-shaped forms. You just go to the points and moving for one to another. I think it's easier to think by this way instead of trying to create lines.
Well,
to your shape.
I'm open to trying other people's program in any firmware, any programming language. In fact, I have now generated the limits of the printer, so how many degrees of rotation to move the plater from 0 to the end, and same for up and down, same for X and same for Y. So you have now the limits of the printer, right? And I want to give those out and challenge people on the Facebook group to come up with their own program using any language, any firmware, whatever. And who comes up with the coolest shape would win. I don't know. Maybe you could try something that you could submit to my printer.
Okay. Well, let's see.
Yeah?
Yeah.
Of course, it's easier if you have the printer beside you, but you know, if somebody's looking for a challenge in programming, you know, let me know, because I want to do this, but I don't want to just put it online and then people don't have time or they find that it's too big of a task or whatnot. But if people say, yeah, we want this challenge, you know, maybe I can even find a small Lego set or something that I could give out as a fun gift for the coolest shape that we print.
I will add some of my tiles to it.
Yeah.
I'll send some Cinebrick tiles.
As gifts, you mean, for the winners?
Yeah, as a prize, as a gift. Yeah.
Yeah, that's cool. We'll like that. Or we could be featured in your next movie, Marc-Andre.
It could be done too. I have a vlog now.
Yes, I know. I'm listening to you. Yeah. Canada. That's my Canada flag I made out of Lego. Yeah, so that's about it. There's a new face here that I don't know on are you also from Brazil? Oh, it's Ico. How are you doing? He's muted. Anyways. So guys, I think that's it. It's a wrap up. I don't know how long we've been live now. Do we have an idea of time?
1.5?
An hour?
Maybe.
Almost long.
Anyhow, so if you guys have no more further questions, we can go. We can stop the broadcast.
Okay.
But we can continue talking after. So thank you everybody for joining. And this is bazmarc signing out. Bye.
Bye.